2.1 Properties of Moist Air and the Psychrometric Chart. Moist air properties. Atmospheric air is a mixture of both dry air and water vapor. It is this mixture that is referred to as moist air. Psychrometrics is the name given to the study of the air and water vapor mixture. 7 properties of atmospheric air are shown on the psychrometric chart. These properties are dry bulb temperature, wet bulb temperature, dew point, humidity ratio, relative humidity, specific volume, and specific enthalpy. Dry bulb temperature and wet bulb temperatures. So let's take a look at a basic thermometer. If the thermometer is measuring the air temperature and the bulb of the thermometer is dry and open to the air, the temperature reading is called the dry bulb temperature. If the bulb is surrounded by a water-soaked wick and moving through the air, then the temperature sensed will be different than the dry bulb temperature, and that is what is called wet bulb temperature. The difference between the dry bulb reading and wet bulb readings of the same air is referred to as wet bulb depression. A tool called a sling psychrometer or sling thermometer is used to measure both dry bulb and wet bulb temperature of an air sample. It consists of 2 thermometers side by side, where one bulb is covered by a wet cloth and the other is dry. The psychrometer is rotated through the air to get the readings. Shown here is an example of a simple and very easy to use sling psychrometer that's manufactured by forestry suppliers. You can see other examples of sling psychrometers online. The dew point. If air is cooled at a constant pressure, there is a point at which the water vapor in the air will condense, that is, change from a vapor to a liquid state. Evidence of this change is seen by moisture forming on surfaces. This temperature is referred to as the dew point. Humidity ratio. Humidity ratio is also known as moisture content. The formula for humidity ratio is shown here and looks pretty complicated. But basically, humidity ratio is simply the weight of the water vapor per pound of dry air. Humidity ratio gives us an indication of the actual weight of the water in the air. Presented another way, if we could take a pound sample of air and squeeze out all the water, the humidity ratio would be the amount of water in pounds relative to the amount of dry air in pounds. Since air has typically a relatively small amount of water vapor in terms of pounds, another expression for humidity ratio is commonly used called grains of moisture. There are 7,000 grains of water in a pound. Relative humidity. Relative humidity is discussed more often in everyday life than humidity ratio and is a little easier for most people to understand. Relative humidity is the ratio of the actual water vapor pressure in the air relative to the water vapor present if the air were saturated. Saturated air means the condition of the air when it contains the maximum amount of water vapor that it could hold. The maximum amount of water vapor the air can hold is dependent on the air temperature at a given atmospheric pressure. So in other words, relative humidity is the amount of moisture the air contains relative to the amount of moisture it could contain, expressed as a percentage. To illustrate relative humidity, consider a 6-ounce container. If the container contains 6 ounces of water, the container is full, and therefore we could say it's saturated. If only 3 ounces of water were in the 6-ounce container, the container would be half full, or 50%. Specific volume and specific enthalpy. Specific volume was presented earlier in Lesson 1.1, Review of Fundamentals. Specific volume is the inverse of density, or the volume of air per unit weight of dry air. In the imperial system of units shown on the psychrometric chart earlier, it is in units of cubic feet per pound of dry air. Specific enthalpy on the psychrometric chart is often referred to as heat content of the air per unit weight of air. The enthalpy of the air is actually the sum of the individual enthalpies of the water vapor plus the enthalpy of the dry air. This includes both the sensible heat of the dry air and the latent and sensible heat of the water vapor. The properties of moist air that were just presented can be illustrated in tables or maybe more conveniently in graphical form. The graphical representation of these properties is the psychrometric chart. At first glance, the psychrometric chart can be confusing and intimidating. We will go through the chart and explain what each of the lines and curves shown represent. The chart shown here is the ASHRAE chart. Notice this chart is for normal temperatures and a barometric pressure of 29.92 inches of mercury. This is what is considered to be sea level. Recall that air density changes at different elevations. Because of this, the air properties will be different depending on the atmospheric pressure. If you are working on a project at higher elevations, you will need to use a chart based on lower pressure. These charts are available from ASHRAE and other various sources. Another item to note is that the chart shown here is in the imperial system of units. Of course, charts based on the metric or SI system are also available. Any condition of the air is shown as a point on the psychrometric chart. So, for instance, 75 degrees dry bulb and 50% relative humidity is shown here. Each property is represented by a line or a curve as with relative humidity. Once a condition is found using any two properties, the other properties can be read directly off the chart. So at 50% relative humidity, 75 degrees dry bulb, we can find the humidity ratio, specific volume, wet bulb, specific enthalpy, and dew point can then be determined. On the psychrometric chart, the dry bulb temperature is shown on the bottom axis. Notice that this chart has dry bulb temperature range from 32 degrees Fahrenheit at the farthest left and goes up to 100 degrees Fahrenheit for the highest value. Lines of constant dry bulb are shown as vertical lines. The lines of dry bulb temperature on this chart are in 5-degree increments. Humidity ratio values are shown on the far right of the chart. Since this chart provides humidity ratio in pounds of moisture per pound of dry air, the values are quite small, ranging from 0 and increasing in increments of 0.0002 pounds of moisture per pound of dry air. Relative humidity is shown on the chart as these curved lines. The farthest to the left is the line of saturation, or 100% relative humidity. This chart shows lines in increments of 10%, with the lowest at 10% relative humidity. Lines of constant specific volume, shown here in cubic feet per pound of dry air, are these lines that extend from the upper left to the lower right. The values begin at 12.5 cubic feet per pound of dry air at the left and continue up to 15.3 cubic feet per pound at the far upper right. Enthalpy is shown here in BTUs per pound of dry air. Because the enthalpy and wet bulb lines are very close, the enthalpy values are given in both the left slope line, shown here, and the bottom axis. This allows the user of the table to better read the enthalpy values. Wet bulb temperature lines are shown almost parallel to lines of constant enthalpy. These extend from the saturation curve down to the left. This chart shows wet bulbs in degrees Fahrenheit ranging from 32 degrees in the far left to 94 degrees in the far upper right, and are in increments of 5 degrees Fahrenheit. Moisture on a surface is condensed from the air surrounding it if the surface temperature is less than the dew point. Dew point is the temperature at which the air is saturated with water vapor. Cooling the air past this temperature causes the moisture to condense. Condensation and dew point is important to understand within the built environment. Condensation on window surfaces, pipes, and ductwork must be avoided since this water can result in damage to the building elements. Please note, at saturation, or 100% relative humidity, the dry bulb, wet bulb, and dew point temperatures are the same. This ends lesson 2.1.